Hello class, and welcome to the third lecture, and I'm hoping it'll be the last lecture on externalities. This you should be up to this in week 6 of the semester. Now, in the last lecture, we talked about what is an externality. We also talked about how externalities lead to market failures. That's basically when a market doesn't lead to the most socially optimal solution. And we also talked about how people can solve the problems of externalities on their own. Basically, and we used the example of someone's barking dog. If I'm a neighbor and I don't want the dog to bark, I will pay money to the person to get rid of the dog. And if the money I pay him is more than he values the dog at, then he benefits and I benefit. That's a private solution. Now, the reason why private solutions don't always work is because not everyone has the money to pay to achieve the maximum optimal solution. And so for the most part, most efforts to internalize externalities are done by public policies. They're done basically by the government. So last week we looked at a couple of different examples of Coase theorem. So this is where basically people use the private make a solution by themselves without the government interfering to achieve the socially optimum solution. Today we're going to be looking at public policies to help solve the problem of externalities. So first off, what is an externality? It's when a market, when left to the private case, it leads to an inefficient allocation of resources because markets, the buyers and the sellers, are only thinking about internal benefits and costs. And that's what determines the supply and demand curve. Externalities also include the costs and benefits that other people will face. Well, the government can basically try to solve the externality problem in two different ways. One is by having command and control type policies, basically ways to regulate behavior. So this could be limiting the quantity of pollution that is allowed to be emitted. And we'll talk about how they could do that later. Also putting regulation in place that only certain levels of technology that have low levels of emission can be used. So an example of that is when you actually go to get your car tested at PVI, they're going to be testing how smoky your engine is. If you've got a smoky engine, there is an external cost for everyone else in the city. Basically, you're contributing to the smog in the city. And so to internalize that externality, the government tests vehicles, and if you're giving too much pollution in your vehicle, they say, sorry, we're not going to make this car legal. You either need to buy a new car or you need to go get this car fixed. There's command and control type policies like that, but there's also market-based policies. This is basically where the government tries to move the supply or demand curves by offering incentives or disincentives, and they try to move the internal supply or demand curve in line with the marginal social cost or marginal social benefit curves, respectively. But first off, just as a quick recap on a private solution, remember we talked about Coase theorem? I was thinking, have I ever been involved with a Coase theorem type solution to internalize the external cost? for between parties. And there was actually one time this happened. So I worked for a company called Mighty River Power. This is a hydroelectric power company. They produced about 10% of all of New Zealand's electricity from a series of 9 dams. There were 9 different dams all along this river. That was called the Waikato River. This was my first job when I finished my bachelor's degree. Now, there was dams are fantastic for generating electricity. They're brilliant. Now, one thing that they're not good for is fish. Now, those fish you see in the bottom right-hand corner, they're actually a type of eel called longfin eel or tuna in Maori. And basically, these eels would migrate up and down the river, and whenever they got to a dam, they would go through the turbines and they would get cut up like sushi. They would be killed. Now, this was not an internal cost for Mighty River Power. We didn't care about the fish. However, there was a local tribe. So in New Zealand, it's similar to Iraq. It's mostly made up of 2 people groups, like Iraq is made up of Kurds and Arabs. New Zealand is made up of 2 people groups called Pakeha, which is what I am. I'm someone who originated from Europe, and we migrated many years back to New Zealand. And then there was also Maori, and these were people who came from the Pacific Islands, and they migrated to New Zealand around 500 years ago. Now, basically, the Maori, there was a local Maori tribe called Tainui, and they loved catching eels and eating the eels. It's sort of like a sacred food for them. And so with all of these dams built, they quickly realized that they weren't going to get any fish. The fish was dying. In fact, it was facing extinction. It was a big problem. Well, what happened? We actually came up with a solution. Basically, the Maori valued the tuna, the fish, they said that it was worth about $100,000 a year to them. Therefore, they went to Mighty River Power and they said, here's $80,000. Would you stop running your dam and take down the dam, and we'll pay you $80,000? Well, of course, that's not a solution. A dam like the one on the bottom left hand of your screen, that's worth about $1 billion US. So we said, no, that's not going to happen. However, why does this matter to you? And they said, well, we really care about the fish that you're cutting up. And we said, well, maybe we can help with that. And basically, what we developed was a way for the fish, the eels, to travel around the dam so they could go upstream and downstream. And we actually volunteered to give our engineering services to designing this. So this is actually something I designed, this eel ladder that you see on the right. It's basically a way for eels to swim upstream and go around the dam. And they paid $80,000 to have this built. And we basically made an agreement. So that picture there is a picture of the CEO of the company and also the Maori Queen. Maoris are not like Arabs in that their leaders, their sheikhs, they can be either male or female. And there was actually a female leader of the Tainui tribe at the time. So we called her Queen. Now, that was an example of a COACE solution. So we were happy with Mighty River Power because it meant we could keep running our dams. The Maori were happy because they kept getting good fish, and the eels were happy too. So it was a socially optimum solution. And so that's an example of Coase theorem, where basically a solution is come about by private people coming to a solution. Now, the bit where that doesn't work is what would happen if the Maori valued the eels at 100,000 US dollars a year, but they didn't have any money to try and bribe Mighty River Power, if you want to look at it that way, to stop the dams or to build an eel ladder. Then it's not actually going to work. And that's why usually you need to have a public policy solution where the government gets involved. It's because of the problem of transaction costs. So we've talked about public policy as being command-based policy or market-based policy, and we're going to start off with market-based policy. Basically, market-based policy is a lot easier to understand. Basically, what you need to do is you need to tax things which actually have an external cost associated with them, or you need to offer a subsidy to things that have an external benefit associated with them. Now, this was basically developed by a guy called Arthur Pigou. So he was a famous economist about 100 years ago or so. And so this type of tax is called a Pigovian tax. So basically, you have your natural supply line curving up, and it's only internal costs, but you're not actually allowing for external costs with that supply line. So there's a marginal social cost line which is above the supply line. Now, a Pigovian tax basically increases the cost to produce a good, and so it basically pushes the demand curve up towards where the marginal social cost and marginal social benefit would intersect. I'll show this to you in a graph later. Likewise, in the other direction, if it's a positive externality, if it's an external benefit, you would offer a subsidy. So an example of a Pigovian tax would be something like cigarettes. Maybe not so much here. It's hard to find Kurdish examples because you don't have a lot of taxes in Kurdistan. But an example would be cigarettes. Now, in New Zealand, a packet of cigarettes costs $20. It's very expensive. And so what you've got to realize is that of that $20, $5 is actually the cost of the cigarettes, and $15 is tax. And that money goes to the government. What that does is it basically reduces considerably the quantity demanded. And so there will be less cigarette smoke in the air, and that'll mean that there is less health problems with secondhand smoke. And the money that is used from the Pigovian tax, that is gathered from the Pigovian tax, that is used to treat people who get sick with cigarette smoking. And so basically they're trying to apply a tax which is at the same level as the external cost. For a subsidy, an example would be solar panels. So I've done a lot of research in this. Most countries are trying to encourage people to install solar panels on their roof. There's a lot of external benefits. It basically reduces pollution. Well, solar panels are quite expensive. So to encourage people to buy more of them, they actually give a subsidy. So that brings down the cost of these solar panels. And then the quantity demanded of the solar panels will basically increase because the supply curve has shifted down. So let's have a look at this in graph form. Let's say there's two companies there, and the two companies are called Firm A and Firm B, and they both run coal-burning power plants. So it's from a country which generates electricity by burning coal. Here in Kurdistan, you used to do that actually back in the 50s and 60s in Kirkuk, but these days it's mostly gas generation. Well, the trouble with coal-burning power plants is that they can emit a type of pollutant called sulfur dioxide, and it's quite a bad pollutant. It causes acid rain, and it can actually cause skin irritation. It can, and of course, it also causes global warming. So there's a lot of external cost associated with coal-burning power plants. Now, both of these firms, they are each producing 40 tons of sulfur dioxide per month. Now, basically, you want to do something as the government to reduce the sulfur dioxide emissions. So you've got a couple of policy options. You could have regulation, that's a type of command-based policy, where you tell the plants they need to cut emissions by a certain tonnage. Tell both plants, look, we will let you only emit 20 tons of sulfur dioxide per month. And then suddenly they're going to try and be more efficient to try and produce a good amount of electricity with far less pollution, for example. But then another way of doing this, which is actually potentially easier and also probably easier at determining the actual social optimum, is to actually provide a Pigovian tax. Tell each plant they will have to pay a tax for each ton of SO2 emissions that they emit. Suddenly they're going to have a big incentive to cut down on their pollution because it's going to save money. And you need to set the tax level where you will basically create the right incentive to reduce the SO2 emissions to the socially optimum quantity. So, regulation, that dictates the level of pollution, but a tax gives the factory owners an economic incentive to reduce pollution. So they're slightly different in how they work. Regulation is very popular because it's very easy to determine the level of SO2 or CO2 emissions which is acceptable. We have scientists who can tell us, well, so long as we're only emitting 5 tons of SO2 as a city every day, well, actually it's not every week, it's not actually going to be too bad. Basically the atmosphere can absorb and break down SO2 at that level, and so you can set the level. However, with a tax, basically it's up to the owners of the factories or the power plants to decide how much pollution they want to reduce by, and so you need to set a tax which is just right to basically lower the pollution to the socially optimum solution. And that can be very difficult because often you don't know how much tax is required to reduce the pollution to the required amount. Now, most economists, I should actually say politicians, they prefer the tax approach. The reason for that is it's easier to do. If they set regulation on the factory owners, the factory owners will complain. But if you set a tax, the factory owners will still complain, but you will actually gain revenue. You will make money, and then you can use that money to fix pollution or something else. So, because it's a market-based policy, it can actually be more effective at reducing pollution. So this has to do with basically elasticity. Remember that there is a certain level of pollution that you want to achieve. So, and basically the supply line for something like a power station, because it's a lot of capital cost, it's very inelastic. So putting a tax, it's very elastic. So putting a tax on it will reduce the amount considerably. Now, suppose that that you want to reduce emissions for firm A. Suppose that the cost of reducing emissions, is lower for firm A than firm B. Well, if you have a tax, firm A is going to reduce emissions more than firm B. So the socially efficient outcome will be that firm A reduces emissions more than firm B. The Pigovian tax is a price on the right to pollute. Basically, firm B, they could go out of business if you put regulation in place and tell firm A and firm B, actually you can only pollute this amount. Well, that may be inefficient because firm A could probably reduce its emissions even more and firm B less. And so a Pigovian tax is a way of basically ensuring that you get a more efficient reach of the socially optimum solution. So, like other prices, the tax allocates this good. I use that in inverted columns. That's basically the right to pollute to a firm that values it most highly. So basically, as the firm pollutes, the first reductions in pollution will be a lot less for firm A and for firm B than later. And there will be a point where they say it's no longer worthwhile us trying to cut emissions. We will just pay the Pigovian tax now for what we're polluting. And so you get to a more efficient outcome. So under regulation, in an example where in a command-based policy where the government says, okay, firm A and firm B, you are only allowed to pollute 5 tons of SO2 a week each. Well, that could be a little bit of a problem because that means there is no incentive whatsoever to reduce emissions further, as long as the cost of doing so is less than the tax. So in the example, if you don't have a tax, basically firm A, which has far cleaner burning coal, they would say we can reduce emissions even further, but we don't have any incentive to do that. Meanwhile, firm B is thinking, gee, this is really a pinch. We cannot reduce our emissions to only 5 tons. We could go out of business. With a tax, potentially, firm A would reduce its emissions to 3 tons a week, and firm B to 7 tons a week. You would still be emitting the same amount of SO2, 10 tons of SO2 a week. But a tax means that the market can basically trade for the right to pollute, and in doing so, they can find a more optimum solution where they can generate more electricity for a given level of pollution. So that using taxes is a good way to incentivize cleaner burning technology, because basically the companies that can burn coal with less SO2 pollution, they are going to have a comparative advantage. And So firms will adopt cleaner burning technology if there's a tax to incentivize them buying it. Now, other taxes, they have a way of distorting incentives and move allocations away from the socially optimum solution. So remember, we want to have a tax that will be in line with the external cost, because this will bring the supply line in line with the marginal social cost line. But other taxes, not Pigovian taxes, they can actually move things in different directions and away from the social optimum. However, when there is an external cost, a Pigovian tax can basically move that supply line up to the social optimum solution. And we looked at graphs of those in the last lecture. And the other thing is a Pigovian tax will raise revenue with the government, and that way that revenue can then be used to fix the external cost as well. So we talked about the cost of health problems caused by the pollution of SO2 emissions. Well, that money could go towards government hospitals to treat people for SO2 related injuries. So certain things that could have Pigovian taxes placed on them. What about something like cigarettes? Well, when Hummer buys a cigarette for, I don't know, 1,000 dinar or whatever a packet of cigarettes costs, have no idea, Hummer, he's going to smoke that and he's going to enjoy it. He's decided that the benefits exceed the cost for him internally, and it was worthwhile paying the price for the joy he gets from the cigarette. However, there are external costs associated with him smoking, because he's going to be creating secondhand smoke. His classmates are not going to be happy because they're going to get sick from secondhand smoke. His girlfriend isn't going to be happy because he stinks of cigarettes, and so there are external costs. Now, if you could value those costs at, say, $15 a packet of cigarettes, the way you would do this is the government would place a Pigovian tax on the cigarettes, and that would bring the cost of the cigarettes up, but that money can be used to address some of those external costs. So the big one for cigarettes is not actually Hummer's girlfriend not liking the way he smells, but the real big issue with cigarettes is actually they can dominate the healthcare system, and they take a lot of resources from the government hospitals. Well, if you have a tax, you can use those taxes to fund the hospitals, so you can build bigger hospitals. Another example would be fertilizer. Now, fertilizer, farmers love using fertilizer because it makes the grass or their crop grow much faster. However, there is an external cost associated with using fertilizer. That means when it rains, the chemicals from the fertilizer will go into the rivers, and that pollution will kill fish. It's going to affect drinking water, because people get their drinking water from the river down in Iraq, and people will get sick. Well, a Pigovian tax could be placed on fertilizer, and the money, first off, it will reduce the amount of fertilizer used. It will reduce the quantity of fertilizer being purchased, and so it will reduce the pollution in the river. But also the money gained from the Pigovian tax, that could be used to clean the water. That could be used for building clean water systems in places like Tikrit and Mosul that suffer from farmers in Kurdistan using fertilizer. Another one would be something like hydroelectric dams. Hydroelectric dams, they are often seen as being green energy, environmentally friendly, and they are to a degree, unless, of course, you're a fish. And so fish, they don't like dams because they can't migrate up and down the river. And so whenever you build a dam on the river, the population of fish in the river drops dramatically. Well, a Pagovian tax could basically create an incentive for the world to build less dams and to make electricity other ways. And so, first off, there will be less effect on world fish populations, but also those taxes could be used for, conservation efforts to increase the number of fish stock. Those are examples of Pigovian taxes, and it can work in the other way too, using Pigovian subsidies to bring the price down on things which have external benefits. Oh, a third one would be petrol. Petrol, it creates CO2 and methane emissions, pollutes the atmosphere. In most developed countries, petrol is a lot more expensive than it is here in Kurdistan. I have no idea what it is in Kurdistan, 700 dinar a litre or whatever. Anyway, in New Zealand, it's about $2 a litre. It's nearly 3-4 times the price. Well, most of that big cost is actually associated with tax. I think about 3/4 of the petrol price is actually tax. It's Pigovian tax. And that creates an incentive for us to burn less gasoline. So I don't know what is the most popular car in Kurdistan, but I suspect it might be something like a Toyota Land Cruiser. Only the very wealthy have Land Cruisers in New Zealand. We all drive really small cars. We drive Kia Pintos and Daihatsu Daewoo's and things like that. And also increasingly we're quite keen on hybrid cars like Priuses, because we have been given an incentive to cut down on petrol. And also the tax can be used to treat the environment, to plant trees, to soak up CO2 and other things. So those are Pigovian taxes. Now let's have a look at a gas tax. A gas tax is trying to target 3 external costs or negative externalities. The 3 main ones are congestion. Basically, the more you drive, the more traffic there will be on the road. And that's going to be an external cost felt by other people. So the government has an incentive to try and reduce the number of cars on the road. Also, accidents. You may not realize this, but actually, if you basically larger cars consume more gas. That's easy to understand, but what you may not understand is that the larger the car, the more likely it is that you are going to kill someone if you have a car accident. You will be safer in the larger car, but if you hit someone on a bike, they're more likely to die than if you were in a small car. And that's just about the conservation of momentum. You learnt all about that in dynamics. So there's a socially optimum solution to try and get people to drive in smaller cars. There's an external cost with large cars. And the third external cost is pollution. Basically, you're producing CO2, which causes global warming. So how can we basically reduce all of these things? How can we reduce fatal accidents and pollution and traffic jams? Well, we can internalize the external cost by using a Pigovian tax. So let's talk a little bit more here. about the policy goal. We want to reduce gasoline consumption. How do we do that? Well, there's two approaches again. We can enact regulations requiring car manufacturers to produce cars which are very fuel efficient. So that actually happens to a degree. There are rules about how efficient cars can be before they are, how efficient cars need to be, before they will be legally allowed to drive on roads by the government. But the other way is to significantly raise the tax that is on gas. And I'm not meaning gas, I'm meaning benzene, I'm meaning gasoline here. So A would be a command-based solution and B would be a market-based policy. Now, what are some of the merits, advantages and disadvantages with both? So one of the advantages of having regulation is that it's actually quite easy to determine the level of quantity which is optimum. So you can say, well, actually we can only have 10,000 tons of CO2 emitted in our country every week. Any more than that and we're going to start causing global warming, let's say. So basically 10,000 tons of CO2, if there's a million cars, that means every car cannot emit any more than 100 kilograms of CO2 into the atmosphere every week. That's the regulation we're going to use. Well, that may work quite well. The difficult thing, though, with a tax as opposed to a regulation is it's very hard to know what is the level of tax that is required in order to reduce the quantity being consumed to that amount. It all depends on the elasticity of the supply line, doesn't it? And so that can be quite a challenge to determine. So that's an advantage for regulation and a disadvantage for tax. Now, a disadvantage for regulation and an advantage for tax is, what do you think will reduce gas at the gas consumption at the lowest utility cost? Well, it'll be the tax, because effectively some families will not reduce their gas consumption at all and others a lot, depending on what their maximum benefit is. And so you can actually achieve a more optimum solution with tax, where it's basically user pays. Now, and the other advantage of a tax is you're actually raising capital as a government. You're raising revenue, which you can then use, hopefully, for addressing these problems like pollution or fatal car accidents, or you could use it for building more roads to reduce traffic and so forth. So reducing the external cost even more. Now, who would support and oppose each approach? Well, I can tell you governments really do love taxing. They think it's great because they can raise revenue. And what government doesn't need more revenue? Now, who doesn't like taxes? Well, the people who pay for the tax, basically you and I. However, if there were regulations put in place that cars need to be more fuel efficient, often that creates extra costs for car manufacturers, which are then passed on to consumers like you and me. So just because we're not paying a tax doesn't mean we're not paying more. So keep that in mind too. Now, economists like tax because of the efficiency of the market deciding who is going to reduce gasoline and who isn't, and so you get more efficiency. But also environmentalists love regulation because that is the most surefire way that you know that the quantity of CO2 being emitted will be reduced. And so there's some advantages and disadvantages with both a regulation, a command-based policy, and a market-based policy like tax. So I want to talk to you now about another kind of market-based policy. This is called tradable pollution permits. Now, remember, with regulation, you basically determined what was the absolute social optimum level of pollution, whether that's CO2 emission or what have you. So if you can recall, we had two firms, two coal-burning power stations, Firm A and Firm B, and they were both emitting 40 tonnes of SO2, so a total of 80 tonnes. Now, you want to reduce that emission to 60 tonnes per month. How are you going to do that? Well, you could tax both firms, and hopefully you'll get the tax right, just at the right amount, so that the quantity of emission is reduced to 60 tonnes. But what happens if the cost of reducing emissions is $100 a tonne for Firm A and $200 a tonne for Firm B? Well, really, Firm A should be reducing more tonnage than Firm B, and that's why regulation is often inefficient, where basically you tell two firms to reduce their emissions by the same amount, when really Firm A should be reducing it by a larger amount and Firm B by a smaller amount. Now, with tradable pollution permits, basically you can give permits or permissions to pollute, and you sell these to the company and you as the government. So if regulation requires each firm to reduce by 10 tonnes, then the cost of that reduction would be for A, 10 tonnes times $100, that's $1,000, and B, $2,000. So you're reducing the pollution from 80 tonnes down to 60 tonnes every month, but it's costing a total of $3,000. Now let's look, that's with regulation. Now, regulation, both of them are reducing by the same amount, 10 tonnes. What happens if you have a tradable pollution permit? Well, with a tradable pollution permit, basically 60 permits, one permit for every tonne of emission is sold to the polluters, to Firm A and Firm B. So for every permit you buy, you're allowed to emit 1 tonne of CO2 emissions. So you could, first off, give 30 permits to each firm. So you give them out to each firm, and then you establish a market for trading these permits. So each firm has two options. They can emit 30 tonnes of SO2, three options, sorry. So they use all of its permits to emit 30 tonnes of SO2. So Firm A and Firm B emit 30 tonnes each. Or it can emit less than 30 tonnes and sell unused permits to a company that is polluting more. Or if it's emitting more than 30 tonnes, they can buy additional permits so that it can emit more. So let's look at that example. Let's suppose the market price of a permit was $150. Now, one possible equilibrium, remember, Firm A, it could cut emissions at a cost of $100 for every tonne. It spends $2,000 and it cuts emissions by 20 tonnes. And that means that it has 10 unused permits and it sells them for $1,500. So the net cost for firm A is $500. What's happening over with firm B? Well, they leave their emissions at 400 tons. So they had 40, that should be 40 tons, not 400, 40. Sorry, that zero shouldn't be there, 40 tons. So they were given 30 permits to emit 30 tons, but they will need to buy an additional 10 permits to emit a further 10 tons of pollution. So they will buy them from firm A for $1,500. So the net cost to firm B to keep polluting at the same level is $1,500. So the total cost of achieving the goal of reducing pollution down to 60 tons of CO2 every month is $2,000. Now compare that with regulation, where the cost was $3,000. Basically, you're making a command-based policy into a market-based policy, which can achieve the social optimum in a more efficient manner, because basically the firms that have the ability to reduce pollution at a lower cost, they will reduce pollution even more, and those that can't will buy the additional tradable pollution permits. So this is a way that has many of the advantages of a regulation-based approach, where basically you can determine what is the level of pollution that is acceptable in terms of the social optimum, and then you let the firms fight it out to determine who cuts what. And basically, if you're cutting more pollution, there's a financial incentive for you, because you can now sell unused permits. Now, that is a market-based policy with the advantages of a tax-based, a Pagovian tax, which is also market-based, because basically you get these advantages that come from comparative advantage. Basically, firm A has a comparative advantage over firm B in cutting emissions. So they're specializing in clean energy, if you like. Meanwhile, it also has the benefit of a command-based policy such as a regulation, because the quantity that will be produced in terms of CO2 emissions, SO2 emissions, sorry, is set. So a system of tradable pollution permits achieves the goal at a much lower cost than regulation. Firms with a lower cost of reducing pollution will be able to reduce pollution beyond what regulation would stipulate, and then sell their remaining permits. And firms with a high cost of reducing pollution will have to buy permits. So it creates a really good incentive for firms to be less polluting. And so pollution is reduced, and the reduction is concentrated in the firms where the reduction is achieved at the lowest cost. So a free market for pollution rights, or tradable pollution permits, allocates how the pollution is divvied up, if you like, to produce whatever they're producing, the product, at an efficient outcome. So that's the great advantage of a tradable pollution permit. The difficulty with a tradable pollution permit is it takes a lot of organization to build a pollution permit system, and it also takes a lot of oversight to make sure where basically you've got to provide surveillance of the companies, making sure they are not polluting more than they are legally should. or more than their permits allow. So let's compare now a Pigovian tax against a tradable pollution permit. Well, remember, with most demand curves, a firm's demand for the ability to pollute is a downward sloping function. It's basically the quantity that they're polluting against the price of polluting. So all demand curves slope downwards like that. Now, a tax will basically raise the price, and it's trying to bring this demand curve for polluting up. Now, a tradable permit actually restricts the supply of pollution rights. So it basically makes the supply of pollution, if you like, completely inelastic. There's only one quantity of pollution that is allowed. But it has the same effect as the tax. It brings the socially optimal solution in line with the free market. So one of the issues that policymakers may have is that they don't necessarily know the position of the demand curve, and so it's very hard to determine how much tax you need to apply to a market to achieve a set goal of pollution reduction. However, with tradable pollution permits, you can actually make a target far more precise, and then basically the market, they start trading and selling permits, and they basically tax themselves, and it's a much more efficient system. So let's look at this on a graph. So on graph 1, we have the Pigovian tax. Now, we have the demand for pollution rights, and basically the supply line, or the supply of pollution, that is perfectly, that here it's perfectly inelastic. It's perfectly elastic, sorry. But a Pigovian tax will push that line upwards towards where towards where the optimum solution is. But the issue is we can determine the optimum solution by the quantity of pollution that is acceptable. We know where Q is, but the trouble is we don't know how high the tax needs to be in order to get the equilibrium where those two lines intersect over Q. If the tax is too low, then then the quantity of pollution will be greater than Q. If the tax is too much, the quantity of pollution will be less than Q. And it's hard to get the optimum solution. Now, with a tradable pollution permit, you're not trying to set a price on pollution. Instead, you're setting a quantity of pollution, and it's easy to tell. You can determine through science or air pollution studies, hey, we can only really emit 60 tons of SO2 into the air every year, or whatever. And then basically you would have a perfectly inelastic supply line. And so where that intersects with the demand curve, that creates the price of pollution. That will be the price that people who pollute at more are willing to pay, and people who are polluting less, they will be willing to sell their excess pollution permits at that price. And so tradable pollution permits have a very good track record of reducing pollution. They really do. The difficulty, though, with tradable pollution permits is they do take a lot of administration to organize the market and a system for permits to be sold and bought. And also, you do need to have good oversight of the companies, making sure they don't pollute more than their permits allow. Same with the Pigovian tax. But with the Pigovian tax, it is, even though it's less effective, it's more simple. You basically say, hey, for every ton of SO2 you emit into the air, you've got to pay the government $30 or whatever. And so basically, it's much easier as a politician to set a Pigovian tax than it is to organize a market for tradable pollution permits. So there are some issues with doing an economic analysis of pollution. And I've posted a very good video from Crash Course in Economics on environmental economics on Moodle. Please check that link out. It's very interesting. But basically, a lot of environmentalists find it very difficult to accept the idea of tradable pollution permits, because basically you can buy the right to pollute, and that just doesn't sound correct to them. But basically people have to face trade-offs. There is a value for clean air and clean water, but you need to compare that to the cost of reducing emissions that come from electricity production and transportation from cars and other things. And so there is a trade-off, and there is an argument as to where that social optimum solution is. But with a market-based approach, it's not the government who tells you where that social optimum is, but the market, you and I. And so with the public demanding clean environment, then a tradable pollution permit system is a way of achieving that target at the lowest possible cost. It does take a lot of administration, though. So I'm now going to give you an example. Now this example is not a tradable pollution permit. There is examples of that in the textbook, but this is actually an example of a project that I was involved in. It actually became the basis of my master's thesis, but I was working in Oman before I came to Kurdistan. Now Oman is a country similar to Kurdistan or Iraq, in that it is very rich in natural gas and oil. That's where most of the GDP for the country comes from. And it's also a developing country, meaning that they've got to raise money to basically build infrastructure that hasn't yet been built. And the population of the country is 4 million. So that's actually a little bit more than the KRG, but not a lot more. I'm not sure actually. What's the population of the KRG? Maybe one of you can tell me. Write that in the comments. Now, like the KRG, most of the electricity is generated from natural gas. And the interesting thing is, it is subsidized at the cost of production. So basically, when you buy electricity, the price you pay is the cost of producing that electricity and no more. So it's a government agency, not a company, that is producing electricity, and they're making zero profit. Zero profit. And because of that, electricity is very cheap in Oman. Very cheap. Now, another thing about Oman is that it's really sunny. They have a lot of sunshine. In Oman, it rains maybe 3 days of the year, and there's very rarely clouds in the sky. And so when they talk about solar resource, that's the amount of solar energy being absorbed by the land every day. And for Oman, it is as high as 6 kilowatt hours every day for every square meter. So 6 kilowatt hours is quite a lot of energy, just so you know. So there's a real good advantage for Oman in building solar panels to actually get electricity from the sun. And then basically they could use that electricity to power houses and even industrial areas. However, very few houses currently get solar panels installed. This was back in 2016 because the benefits did not exceed the cost. For electricity from the mains grid that was generated from gas generation, you were paying about 4 cents per kilowatt hour. That is it is so cheap, 4 cents per kilowatt hour. Just to give you an idea, every month my electricity bill for me and Sarah in our apartment was less than $5. I paid $5 for electricity every month. And that's keeping in mind we were in Oman where it was very hot, so we had the AC going all the time. Now, with solar power, it costs up to 20 cents per kilowatt hour. That's because solar panels and setting up the equipment and the batteries, it's actually quite expensive. And so the sums just don't add up. Why would you ever want to buy expensive solar panels, put them on your roof and set up this expensive system only when you're going to have to pay more for electricity than if you were just going to get it off the mains grid? Well, that's the issue of market failure, because basically there were a lot of external benefits with solar energy, and the government was realizing this, that are not being included in that cost. So basically, when you only look at internal costs and benefits, solar power just didn't add up. But include the external benefits and suddenly you've got an incentive. Now, in 2016, the Omani government, they launched a scheme called the Saham Initiative. So Saham in Arabic, if you don't know, that means contribute. So basically it was a system for people to have an incentive to build solar panels on their roof, and if they weren't using the electricity from the solar panels, that power would go to the mains grid. So everyone would be a generator as well as a consumer of electricity, and so you would contribute or saham to the overall electricity resource in Oman. And it was a subsidy scheme. Basically what they were trying to do was to create a Pigovian subsidy. Now remember what I said, that as I said, it's the same with Pigovian taxes. It's quite hard to price a Pigovian tax or a Pigovian subsidy to the right level so you get the Pareto optimum, the socially optimum solution. So that's where I came in. This was actually a contract that I did with the Electricity Authority of Oman. So with the Saham initiative, they were trying to price a subsidy so that they could pay people. They could reduce the price of solar panels and other equipment associated with solar energy, and that subsidy would basically be the quantified amount of external benefits. So one of the first external benefits of solar panel is a greenhouse gas emission reduction. So if you're using electricity that you got from solar energy as opposed to gas energy, well, that means there's going to be less CO2 emission into the atmosphere. And most environmental economists are currently saying that for every ton of CO2 that you emit into the atmosphere, it's costing the world, or it's costing someone in the world, $20, more or less, either in yeah, more needed air conditioning or whatever. Now, you also have an external benefit in that the gas that is not used in the for burning for making electricity in Oman, that could actually be sold on the international market. You can make it into liquefied natural gas and sell it to other countries. Obviously, if you do that, you can't say you've reduced overall greenhouse gas emissions, but that is an external benefit. Remember, the Oman was selling gas to its residents at around 4 cents per kilowatt hour. It was selling electricity at 4 cents per kilowatt hour. Instead, they could make a lot more money, and I mean a lot more, by selling the gas on the international market. Now, the other thing where there's good external benefits is savings in transmission and distribution. So, where is the nearest power station to Erbil? I'm not sure. I think the power station for Erbil, the main one, is on Mahmour Road, and it's quite a long way out from the city. I think it's about 10, 15, 20 k's out from the city. Now, that electricity needs to actually be brought up to Erbil by transmission lines. And just like any road, there's inefficiencies in the wire. That can actually reduce the amount of electricity. It can actually reduce it as high as 10-15%. And so there's a loss of energy in transmission. If everyone was generating electricity at the point of consumption, meaning at the house, so you're generating electricity on the roof and in the house, you're using that electricity, you're going to save a lot in transmission. The other thing is it reduces peak demand. So one of the big issues in Oman is a similar issue in Kurdistan. When do you have power cuts in Kurdistan? Well, it's usually in the summer, and it's usually in the afternoon, where basically the temperature is at its hottest, because the demand for electricity is highest when the weather is hot because of air conditioners. Now, that causes power cuts, and that can affect industry. Here in Kurdistan, that's the main reason you don't have a lot of manufacturing industries, is because you have unreliable power, and you just can't rely on a diesel generator for a factory of even medium size. You need to have mains electricity, and you need it to be reliable. If you don't have that, then you've got a problem. They had similar issues in Oman. Basically, they were thinking they were going to need to build a new power station because the peak demand was getting so high, and that was going to cost a lot of money. And so by delaying the building of a new power station, they were going to save money. That was an external benefit of getting people to install solar panels. And so, yeah, a capacity upgrade project is another way of putting it. So the Electricity Authority of Oman hired me to basically work out the value of all of these externalities. This is really my specialty, is engineering economics, more so than some of the more technical fields within civil engineering. So in 2016, they got me to value all of these externalities, and basically I worked out that there was basically a value for solar panels of basically, this is the private internal benefits plus social benefits of about $7,000 per kilowatt peak. So that's there's a benefit of about $7,000 for about every 6 square meters of solar panels that are installed in Oman. And this figure basically became the basis of the Saham subsidy. And I'm really glad they took my recommendation. Basically, the government said if anyone wants solar panels, we're going to basically pay about 75% of the cost, because it cost about it cost a fair amount. But because of all of the social benefits, the government said we will pay for it. And the government didn't care because it was remaking that money in savings and gas, which they could then sell on the international market, and not having to build a new power station, which they thought they might have to. Now, initially, it was houses were making electricity. They were buying electricity from the grid, from gas-generated electricity, for 4 cents per kilowatt hour. Very cheap. And so they said, why would we ever build solar panels? Because it would cost us 20 cents per kilowatt hour. Way too much. But now, with this Saham initiative, with the subsidy, this Pigovian subsidy, it brought the overall solar-powered cost down by nearly 1,000%, and so it now only cost about 2 cents per kilowatt hour. And suddenly it was cheaper to generate electricity using solar energy than it was to buy electricity using gas. And so I'm actually quite proud of this. Since 2017, the Saham initiative has been a huge success. 20% of all Omani households now have solar panels installed on their roofs. And it's actually a far greener country than it was before. So I'm quite happy about that, and I'm very proud of what I was able to contribute to bring that about. So that's an example there of a Pigovian subsidy. Of course, there's a lot of work in basically valuing the externalities. Now, some little supplementary reading. Read pages 106 to 110. I have photocopied these pages. They are available for you on Moodle. Also, watch the crash course in economics videos on Moodle. There's a very good one on externalities. So please do that as well. So thank you everyone, and if you've got any questions about externalities, please let me know. I recognise this is probably one of the harder parts of engineering economics, so I'm here to help. God bless and goodbye.